Can you see my screen?
네,
화면
보입니다.
예, 시작하도록 하겠습니다. Nice to meet you. My name is Tae Seongjun Yang. Today class is GNN practice class. This class consists of three things. In first section, we will make a graph convolution equation. More detail, we will make a graph by using networkx library and by using adjacency matrix, node index, and node embedding vector from graph. We will follow the aggregation and combination step in graph convolution equation. Finally, we will make a Gaussian layer. Actually, it is not practical. So in the next section, we will make node classification in Cora dataset by using PyTorch practically. In this section, I will introduce Cora dataset and we will implement GCM model with Cora dataset and visualize node embedding. And next section, it is homework. In this section, I will introduce some brief information about the code and PyTorch geometry. Let's begin. First, install package and import package. And next, it is a graph convolution equation. From here, we will make graph convolution equation step by step. First, by using networkx library, we will initialize graph. And we add node in graph. We add 6 node. It is similar with this. And next, we will add edge. Likewise, it is similar with this. And next, we print. By printing, we can see the number of node and number of edge in graph. And we can print node picture and we can plot the graph. And next, by using ATTR matrix function, sorry. By using ATTR matrix, we can see adjacency matrix and node picture matrix. From the result, we split adjacency matrix and node picture matrix. By doing this, we can see split adjacency matrix and node picture matrix. It is similar with this adjacency matrix. And next, we do matrix multiplication of adjacency matrix and node picture matrix. We can see the result. Question, is this the node representation? No, it is just neighbor aggregation. So we need combination step. It is same as this. And next, first, we must add self-loop edges. By doing this, we can add edges in adjacency matrix. And by printing, we can see 1 by 1, 2 by 2, or 3 by 3, and so on, or self-added edges. And next, by using two functions, we can see adjacency matrix with added self-loop edges. And next, also it is look similar with this. This. And next, we do matrix multiplication of A hat and node picture matrix. Then we can see the result. But there is another problem, because the scales of node picture differ by number of neighbors, so we need normalization. First, we must get degree information. By doing this, we can extract degree of each node. One node has 3 degree, two node has 4 degree, number 3 node has 4 degree, and so on. And next, by using numpy dialog function, we can get a degree matrix. And next, by using this function, we can get inverse degree matrix. And next, we do matrix multiplication of inverse degree and A hat matrix. Then we can see the result. It is looks similar with this. And next, we do matrix multiplication of this and this. Then we can see the result. It is result of all linear operation, and it is normalized result. From here, we will make our decision layer. First, we initialize weight, and next, it is decision layer section. In this section, you will make your code. First, it is ReLU activation function. Actually, we need non-linearity activation function. But when I searched some material, ReLU is used for activation function generally in GCN. So I use ReLU. Don't mind this. We just focus on making your GCN layer. I will give you 10 minutes. Let's do it. 이 부분 같은 경우에는 그러니까 요 엘리멘트가 1, 2, 3, 4, 5, 6, 5 돼 있는데 그 인덱스 접근할 때는 -1을 해줘야 돼서 그러니까 뭐라고 말씀드려야 되지? 예, 맞습니다. 1부터 시작합니다. Time is up. I will copy and paste my code. Wait a second. If you type this code, then you can see the node embedding from GCN output. And next, we can visualize our node embedding by using this function. You can see the node embedding. By the way, there are 5 nodes on the screen because node 3 and node 5 has same embedding. So 2 nodes overlap on the screen. And next, in next section, we will do node classification on Cora dataset, import package, Cora dataset. I introduced Cora dataset. If you click the link, you can see the same explanation. In my opinion, it doesn't come close to well, so I give you simple explanation. Cora dataset is about a publication citation graph. It has 2,708 paper loads and 5,429 citation link. Also, it has specific word occurrence metrics per each paper load. It is node feature matrix. When applied to a graph, paper becomes a node and citation becomes edge. Also, word occurrence matrix is node feature matrix. By running this, we can download Cora dataset. And next, by using pandas, we can see what the Cora dataset looks like. First, a Cora comma size file. By running this, we can see node index and source node index to target node to node edge index. So in the table, we can see node and edge information. And next, by using this function, we can extract node index list. And next, we can see Cora comma contents file dataset. If you see the table, you can see node index and word occurrence matrix, and lightest of table has node class type. If the paper has specific word, it has one value. And next, by running this, we can see total class type. It has 7 class type. In the class, we will predict the subject of paper on the basis of surrounding node data and the structure of the graph. And next, it is hyperparameter for our GCM model. And next, preprocess and make dataset section. Actually, graph preprocessing varies depending on the graph data. So in this class, focus on making GCM layer. First, include one-up function. Each function make all class to one-up vector for training. And next, normalize function is similar to normalization process implemented earlier. It is row-wise normalization. And next, each function converts SciPy sparse matrix to touch sparse tensor. And next, it is load data function. In this function, build rep and build adjacency metrics and split all load to train valid test for load classification. Unlike image and natural language, graph dataset are difficult to split graphs, so it is assessed by index. And next, it is accuracy function. And next, it is our graph convolution and GCM model architecture. In this section, you will make your code. In this section, you just fill the twofold function. I will give you 10 minutes. Let's do it. 아, 글쎄 제가 질문이 어떤 의미인지는 잘 모르겠는데 일단은 W는 웨이트가 맞는 것 같고 어, 음, 요거는 그 강의 끝나고 저한테 메일 주시겠어요? 이거 좀 질문이 이해가 안 돼서. 네, 죄송합니다. Time is up. I will copy and paste my code. Finished. In this section, I use dropout layer for preventing overfitting. And next, it is setting for training model. It is for initialized weight and raw data and define with our hyperparameter and define optimizer and load model and data on GPU. And next, train code section. In the train function, we train Gaussian by using NNL loss and Adam optimizer. Uh, by using a train index and validation index, we can get from output, we can get train loss and train accuracy. And by using train loss, we can do backpropagation and it is evaluation. NLL 로스는 지금 제가 바로 설명하기는 좀 그렇고 메일로 제가 드리거나 솔직히 구글링 하면 쉽게 나오기는 합니다. 제가 메일로 자세하게 보내드리도록 하겠습니다. And next, test code section. In the text function, we trained the model with node embedding visualization. It is looks similar with train code. And next, in train, if you see the result, train loss decrease well and validation accuracy increase well. And next, test section. By doing this, you can see test accuracy and test loss. And when looking at node embedding visualization, we can see the scattering of 7 node class. And next, it is homework section. It is the graph classification on correct dataset. I introduced correct dataset It is very large data set containing many graphs and graph label. The graph set is mainly used for graph classification. The graph classification code is made on PyTorch geometric library. Why do I use? Because graph data set is very huge, so training speed is very slow. By the way, PyTorch geometric is very fast despite working on sparse data. Compared to DGL library, uh, each PyTorch geometry 15 times faster. So I recommend learning code with studying the PyTorch geometry library. I give some more information. In this section, because the crop data set does not have node feature, so I make a node feature using the max degree value. I reference that in this material. And next, in this section, to mention again, unlike image and language dataset, unlike image and language dataset, in graph, data in graph, it is tricky to split graph and make data loader. But by the way, in PyTorch geometry, each data loader can aggregate node feature, weight, and edge index from different graph into batches. So I want to see the reference material. It is reference material of my practice class. It is end of my class. Do you have any question? 아, 어, 근데 저도 지금 정민님 질문을 봤는데, 그러니까 NN 리니어 가지고도 웨이트를 만드실 수 있다라는 말씀이시죠? 사실 제가 해본 적이 없는데, 어, 해당 부분에 대해서는 어떤 차이가 있는지 제가 좀 더 조사해서 말씀드리도록 하겠습니다.
말씀드리면 아마도 리니어로 하면은 바이어스, 웨이트나 바이어스까지 같이 딸려 들어오고, 저렇게 영시적으로 파라미터를 디클레어 하면은 웨이트만 있고 바이어스는 없을 겁니다.
네, 감사합니다.
네.
네, 그냥 이제 집에서 실행시켜 보시고, 그냥 파이토치 지오메트릭 한번 보시라는 차원에서 그냥 첨부했습니다. 네, 일단은 제가 말씀드릴 거는 오늘 수업에서 말씀드릴 건 다 말씀드린 것 같습니다.
네, 그럼 혹시 are there any more questions? All right, I guess that let's thank TA Songjun for his material today. And yeah, as I announced on Classroom, the specs of project number 2 would be announced probably sometime around this weekend. So pay attention to Classroom. And as is, if I remember correctly, next week is an off week due to the undergrad interview schedule. Is that correct? Is everybody on the same page? 다음 주 학부 면접 때문에 전부 휴강인 거죠? 네. 저희가 그래서 okay, so 수목만. Is it the whole week or just the Wednesday and Thursday? 네, 저도 다 없는 걸로 알고 있는데요. 네. 저희가 지금 수업이 하나 남았는데, so we have one more class to go, and it's about neural OD. So we could do it next week, or we could do it the week after next week. 그러니까 다음 주에 해도 되고요, 그냥 휴강 없이. 아니면 다다음 주에, 그 다다음 주면은 네, 다다음 주면 이제 마지막 주죠. 기말 주인 거죠. 그때 해도 되는데 뭐 클래스홈에 또 올리긴 하겠지만 언제가 좋으신가요? 옵셔널 클래스로. 네, 하긴. 근데 뭐 언제든지 다시 유튜브로 보실 수는 있으니까 뭐 언제 해도 상관없긴 한데요. 음. 네, 일단은 그러면은 뭐 지금까지 항상 그래왔지만 뭐 클래스는 항상 옵셔널입니다. 제가 뭐 출석 체크를 하는 게 아니기 때문에 일단 다음 주에 하는 걸로 제가 공지를 하겠습니다. Okay, yeah, so as I just said in Korean, we will just finish our class, do our last session on neural OD next week. And of course, as always, it's optional. You can always, if you can't make it, then you can check back on YouTube, and material will be uploaded on Classroom as always. Okay, all right, then I'll see you guys next Tuesday. Bye-bye. 네, 네, 성주님 수고하셨습니다.